Thanks for watching this screencast. This screencast is about graphing piecewise functions. And the objective is that learners will be able to graph a piecewise function given its function rule. So Panthers, a function that is written using two or more expressions is what we call a piecewise function or a piecewise defined function. Those terms are kind of used interchangeably. And you see on the screen an example of a piecewise function. Here is the rule of the piecewise function, and actually maybe I should say rules, because it has two rules. It has one rule to follow if the x value, the input value, is less than or equal to 1, and that rule is take the opposite of x and then add 2. And you can see that in the red part of this graph. This graph was made on Desmos, but it shows the first half of the function rule here. For all the x's that are less than or equal to 1, including the point when x equals 1, the y values on the graph are the opposite of the input value plus 2. When x is 0, the opposite of 0 is 0, and 0 plus 2 is 2. When x is negative 2, for example, the opposite of negative 2 is 2, and 2 plus 2 is 4, and so forth. So this half of the graph right here is the half of the graph that goes with this part of the rule. And then the other part of the graph that's in blue goes with the part of the rule that's in blue. For all the x's that are strictly greater than 1, give me the input value minus 3. So when x is 2, 2 minus 3 is 1, the y value. When x is 5, 5 minus 3 is 2, and the y value is so forth. Notice the importance that at the value x equals 1, we've included the point that has x equals 1 in its domain, if you will. And we've excluded the value that is not a part of the second rule when it says x must be strictly greater than 1. So our goal in this screencast and this objective is to be able to graph things that look like this, graph these piecewise functions. So I thought it might be really helpful to, with my color coding here, use different colors to indicate these. If you're practicing along at home and you've got a couple different colored pencils or something else, some way of contrasting these two parts of the graph, that might be a good way to practice and play along. I'm going to try to make each one of these rules here in different colors. I'm going to start with the rule that says if x is less than negative 1, then x should be greater than 2. And I kind of envision almost like maybe I want to work this way backwards. Starting at negative 1 and working my way backwards to the other x values that are less than negative 1, I want to take the input values and subtract 2. So when x is negative 1, negative 1 minus 2 is negative 3. I'm going to put a little dot here, and since the part of the rule that defines this part of the graph doesn't include x equals 1, I'm going to leave that as an open dot. Now the rest of the graph I'm going to connect with a solid line. So let me work my way back. When x is negative 2, the opposite of 2 minus 2 is negative 4. So I need y equals negative 4 there. When x is negative 3 minus 2 is negative 5. You see what's happening here, don't you? When x is negative 4 minus 2 is negative 6. So half of my graph should almost be this part of a line. I didn't draw it too well there, but you get the idea, don't you? Now for the other part of this rule, what I need to do is I need to take all the x's that include negative 1 and are bigger than negative 1 and use this rule. Give me x plus 3. So let's go back to when x is negative 1. If x is negative 1, negative 1 plus 3 is positive 2. And since since negative 1 is is involved in this rule with the equal sign, I'm going to make this one a filled in dot. And now I'm going to work these x's, and I'll connect this part of the graph as well. When x is 0, 0 plus 3 is 3. When x is 1, 1 plus 3 is 4. When x is 2, 2 plus 3 is 5. That's probably enough to get an idea of what's happening here, isn't it? These are both linear. So from this point only, don't extend it back here. Back here, the blue rule didn't apply. only the blue rule applies this direction. So here, connect those with a nice line, and make sure you show that that extends on forever as well. And that's a pretty good graph of this piecewise function. Let's do another one together. This one says the rule is f of x equals x plus 2 if x is less than or equal to 0, but it equals x if x is greater than 0. So I'll kind of separate these into two parts here. I'll do a red part, and I'll go back and do the other part. What the heck? Do this one in green. Why not? Maybe you're reviewing this close to Christmas time. X plus 2 if x is less than or equal to 0. So let's start over here at x equals 0. And if x is 0, 0 plus 2 is 2. And since this part of the graph includes that point, this time I want to make the filled in dot. And I'll work my way backwards for all the other x's that are less than 0. If x is negative 1 plus 2 is 1. If x is negative 2 plus 2 is 0. If x is negative 3 plus 2 is negative 1. I see what's happening here. I'll do one more. If x is negative 4 plus 2 is negative 2. This half is linear. I know that from looking at the rule as well. So let's go like this. There's half of my graph. Now let's do the other half. And the rule here is pretty simple. If x is greater than 0, just give me the same value that you put in as the output value. Just give me x. So when x is 0, well, y is 0. Now I don't want to make this a filled in dot. This says only for the ones that are greater than 0. So let's put a little open dot at 0, 0. But when x is 1, y will be 1. When x is 2, y will be 2. When x is 3, y will be 3. And so forth. So starting at this open dot, well, that was lousy. Let's try that again. Okay, still lousy, but you get the idea, don't you? And there's the second graph, pretty good. All right, Panthers, I'd like you to pause this video now and see if you can make a sketch of what this function would look like. Try to make the sketch if you can. And then when you think you've got a good handle on it, hit play and we'll check it out. Okay, how'd you do? I'm going to do each part of this in a different color to help distinguish which part came from which. Part of the rule for this piecewise function is that if x is less than or equal to 3, then I need the output value to be 1 less than the input. So I'll start at 3 and kind of work my way backwards. When x is 3, 3 minus 1 is 2. Should I fill in that dot? Yes is the answer, I should. And one more time, why? Well, this is the part of the rule that includes when x equals 3, so I should fill this dot in. When x is 2, 2 minus 1 is 1. When x is 1, 1 minus 1 is 0. When x is 0, 0 minus 1 is negative 1. And I see the pattern, don't I? So part of the graph should look something like that. Now, Panthers, this second part of the rule is interesting, isn't it? It says if x is greater than 3, just make the output value 1. So for the x values that are greater than 3, and we should do a point at 3 also, just give me negative 1 as the output value. If x is 3, then the rule for this one is give me negative 1. I'm not going to fill this dot in because negative 3 isn't actually one of the x values that this rule works for, but it works for all the other ones too. If x is 4, y is negative 1. If x is 5, y is negative 1. If x is 6. This half of the graph is still linear, but it's a horizontal line. It goes this way. And that's what the graph ought to look like. As always, thanks for watching.